Advanced farming techniques have revolutionized agriculture, improving efficiency, sustainability, and productivity. Here are some key aspects of advanced farming in the world today. Precision agriculture, GPS and GIS technology. Use of global positioning systems. GPS and Geographic Information Systems gives for mapping fields, monitoring crop health, and managing inputs like water, fertilizers, and pesticides precisely. Drones and satellite imaging. Drones equipped with cameras and sensors for real-time monitoring of crops, identifying issues such as pest infestations, nutrient deficiencies, and water stress. Satellite imagery provides large-scale monitoring over time. Smart irrigation systems, IoT sensors, Internet of Things IoT devices monitor soil moisture levels, weather conditions, and crop water requirements to optimize irrigation schedules and conserve water. Automated irrigation systems, drip irrigation and other automated systems deliver water directly to the root zone, reducing waste and increasing efficiency. Genetically modified crops. GMOs, enhanced traits, crops engineered for higher yields, pest resistance, drought tolerance, and improved nutritional content. CRISPR technology. Advanced gene editing techniques like CRISPR-Cas9 allow precise modifications to enhance crop traits. Vertical farming, hydroponics, and aeroponics, soil-less farming methods where plants grow in nutrient-rich water or mist environments, allowing for higher density planting and reduced space requirements. Controlled environment agriculture. CEA, indoor farming with controlled light, temperature, and humidity to optimize plant growth and increase year-round production. Robotics and automation, autonomous machinery, self-driving tractors, harvesters, and planters that reduce labor costs and increase efficiency. Robotic harvesters, machines that use AI and machine learning to pick fruits and vegetables accurately, minimizing damage and maximizing yield. Artificial intelligence and machine learning. Predictive analytics, AI-driven models predict crop yields, disease outbreaks, and optimal planting times based on historical data and current conditions. Farm management software, platforms that integrate data from various sources to help farmers make informed decisions about planting, harvesting, and resource management. Sustainable farming practices, conservation tillage, reduced tillage methods that minimize soil disturbance, preserving soil health and reducing erosion. Crop rotation and diversification, strategies to improve soil fertility, manage pests, and reduce reliance on chemical inputs. Organic farming, practices that avoid synthetic pesticides and fertilizers, focusing on natural inputs and biological processes. Alternative protein sources, plant-based proteins, development of plant-based meat alternatives using soy, peas, and other proteins. Cultured meat, lab-grown meat produced from animal cells, offering a sustainable alternative to traditional livestock farming. Blockchain technology, supply chain transparency. Blockchain ensures traceability and transparency in the food supply chain, allowing consumers to track the journey of their food from farm to table. Smart contracts, automated contracts that facilitate transactions between farmers, suppliers, and buyers, reducing the risk of fraud and improving efficiency. Renewable energy integration, solar and wind power. Farms adopting renewable energy sources to power operations, reducing reliance on fossil fuels and lowering carbon footprints. Bioenergy, use of agricultural waste to produce biogas and biofuels, contributing to a circular economy. These advanced farming techniques are transforming agriculture, addressing challenges like climate change, resource scarcity, and the need for increased food production to support a growing global population.